dinosaurs and not in others?
The whys of evolution are not an easy question for science to address, because sometimes there may not be a why. It may just be sort of a happenstance of evolution that some of these features evolved and then happen to be advantageous. What we do know, at least about these features, is that they didn't evolve for flight, and they just happen to be able to kind of be utilized for that behavior in the earliest birds.
But if feathers appeared in raptors, for whom flight was an aerodynamic impossibility, did they serve some other purpose?
Right now, sort of the leading ideas about why feathers might have evolved have to do with their role in thermoregulation. Around the time that we see the first feathers showing up in the fossil record, within these group of dinosaurs, you're seeing a big shift from being a very big theropod like Allosaurus to going to be very small. So you're going from being multiple tons in mass to being maybe just 10 or 15 pounds. As you get smaller, it's much harder to maintain high body temperatures, and these are probably fairly active animals. And the evolution of feathers was somehow adaptive for maintaining body temperature as these animals got small evolutionarily.
Flight feathers were the last stages of feather evolution. Millions of years later, the evolution of the modern feather signaled the turning point from non-avian dinosaurs to Archaeopteryx, an animal that is recognizable as one of the earliest birds.
What we're looking at here are casts of the first and probably one of the best Archaeopteryx specimens found. These are preserved in very fine-grained limestones, and that preserved these impressions of the feathers that these animals had. What's probably most significant is all the things it doesn't have. You can look at its skull, and it still has teeth, just like all the other theropods do, but not like modern birds. So it really is this sort of kind of perfect transitionary animal.
Just as these prehistoric